Hello, welcome to remote oil tank display project. The scope of the project is to display the oil level from a very remote location. So the oil level is monitored by a level sensor. This is the level sensor. This basically works on the principle of capacitance. These two rods will act as two parallel plates, and the liquid in between the two will act as a dielectric. So as the level of the liquid varies, the capacitance of this sensor would vary, and the variation in capacitance is in turn reproduced as a voltage variation. This voltage variation is then converted into digital format by an analog to digital converter. This digital data is then read by a microcontroller, which then communicates the information to a wireless transmitter. From there the data is transmitted in a wireless mode. So this section is the transmitter section, and this section is the receiver section, and the data which is sent via the wireless transmitter is received by this receiver. The received data is then in turn received by the microcontroller, and the microcontroller in turn update the data into the LCD display, and if the level of the tank exceeds 100%, then it would indicate the user by means of a buzzer here. So this is the nutshell of the project. So the ultimate objective of the project is to measure the level of oil tank and to communicate that information in a wireless media. Okay. Now let us have an insight of each and every hardware section one by one. This is the transmitter section. The objective of the transmitter section is to measure the level of the oil in this particular tank and then communicate that information via wireless mode to the receiver. So there are three boards here. This is the main microcontroller board, this is the ADC board, this is the transmitter board. The usage of this ADC board is to convert the analog data that is coming from the level sensor into digital. The microcontroller receives the digital data and then sends the data to the wireless transmitter. The wireless transmitter in turn sends the information to this antenna by a transmitter module. This is the transmitter module, and we are using an encoder IC here which encodes the wireless data. Okay, so coming back to the main microcontroller, we have a power input here. We have to supply 12 volt AC, which is then converted into DC by a 4 bridge rectifier, 4 diodes, which then act as a bridge rectifier, which is then filtered by a filter capacitor, which is then regulated by a couple of regulators. One is 7812 regulator, which gives you 12 volt output. The other one is 7805 regulator, which gives you 5 volt output. This 5 volt output is then used for supplying this power for the main microcontroller as well as this transmitter as well as this ADC. So we are tapping power from here. So all the power are distributed from this main board. And this is the microcontroller. This microcontroller is a 40-pin microcontroller. Couple of parallel ports. These are the 4 parallel ports. Couple of parallel ports are used for the ADC, and couple of parallel ports are used for the transmitter section. And for the operation of the microcontroller, we need a reset circuit. This capacitor, along with this resistor, along with this reset circuit, along with this push button acts as a reset circuit. This is a crystal oscillator which supplies clock pulses to this microcontroller. Okay. Here is the ADC. This ADC is 0804, which converts the analog data into digital. The data that is coming to the microcontroller is in turn given to the wireless encoder. This wireless encoder is HT Holtec 640. This IC is then used to communicate the data via the transmitter section. Now coming back to the receiver, we are having a receiver section here. This is the receiver module. The receiver module receives the data via wireless mode, which is then decoded by a decoder IC. The decoder IC is HT648 decoder IC. And the decoded data is then given back to the microcontroller, and the microcontroller analyzes the data and then updates the data to the LCD display. And the LCD display is used to display the oil level of the tank. And if the level exceeds threshold, in this case we have set the threshold as 100%. That means if the oil level exceeds 100%, the microcontroller would automatically fire a buzzer here so as to indicate the user. Now let us see the demo of this particular project. First one is you have to insert the power adapter for the transmitter section, and you turn the power on. Similarly, you have to connect the power adapter for the receiver section, and you turn the power on, and you can see this LCD display showing that oil tank level, the level is 0% and the buzzer status is off. Now we will pour some liquid here and see what happens. Okay, I am now pouring the liquid here. You can see that the level is getting increased gradually, and at one particular point of time, when the level exceeds 100%, we will have a buzzer indication. Okay, in this case the fluid is 96%, and you can see that when the fluid exceeds 100%, you are having a buzzer indication. And once you reduce the liquid level, you will have the buzzer indication going on. Again, when it reaches 100%, it will have a buzzer indication. So that's it. If you have any queries, please get back to us. Thank you.